Okay, so welcome to the second third of the class today. Now, I want to show you a little bit of how, say, mathematical programming works. So one of the example I might do is, this is actually from my, I guess, my son's high school project. So we look at that analysis of global COVID data. But before we do that, let's free form a little bit. Okay. Now, just now, every time you enter something in here, you're actually doing a programming. It's expected again with the manner is, the expectation is when you print something, you type in something, it's a programming code. A is equal to 5, right? But you can do this. I don't know if you can see this, but there's a, let me make it larger. It's so glaring white, I can't see a thing. Hold on. Okay, you see a plus sign here? It's a bit glaring here. Okay, now if you click a plus sign, there's an option. Right, there's an option. So, well, first of all, bottom here is a text. So instead of putting the bracket and star, you can literally just say plain text. Okay, and in that case, it's just gonna treat it as a text. And this is the concept called computational computable document format, meaning you can literally use this as a word processor. Okay, think of a textbook, right? A textbook in algebra, right? It's a PDF. But when you go to the equation, you can't do anything with it, right? Okay. Well, think of a textbook that allows you to manipulate the function. So I can say, you know, algebra, high school, algebra, or something like that, right? And then I teach something like y is equal to mx plus b. By the way, I don't have to, if I put a space, it's multiplication. So just to keep it. Okay? So something like this. This is a linear equation, right? So you see this and you see a plot. Okay. So you can see square, say. Okay, so it's a hyperbolic. A plus b x plus c. Now, I want to teach students how to do this, right? I can just put in some number A, B, and C. Okay. However, wouldn't it be nice if I do this? Say I define linear. Okay. Well, I don't have to say. I just say, what's it? A x squared control arrow square plus, let's call it A1, A2 x squared plus A1 x, okay, plus A0. Okay, right? But now I don't want to make it a date. Say, let's say I'm say quadratic equation. Let's teach. Okay, so let's teach. So let's say some text, some text. Okay. Now I explained this. This is good. This is important for, well, you know who's the first one who used it successfully? Probably French army field artillery. You know, they had to calculate the projectile of cannons. Okay, so French army, I think they were quite good at calculus. Anyway, so I want to do this, but I want to graph this, right? But I don't. So I want to do this. So I'm gonna say I'm gonna plot this. P-L-O-T plot. Okay. Now I have to plot. I have to give it a range. So see, it's giving you a little indication that it's expecting something, right? See, watch this. Yeah, I'm typing it, right? This function requires 2 arguments, 2 spots. I gave it 1 spot. This is spot where equation lives, and I close it. Oops, I close it. Say, no, there's something else. I need to do something else. Well, because I can't just plot, you know, from anywhere to anywhere. So I have to say A, and this is a syntax. Again, this is X from say -3 to +3. Okay. Now, right now, it doesn't know what A is. Okay. So I can do this. A2 equal to 1. A1 equal to 2, 3, whatever. A0 equal to 5. Okay. I can do this. Again. Okay. So I got my function. Right. Now, this is kind of like boring because it looks like a static text. What if I want to say what happened when A is equal to 7? A1 is equal to, you know, say -1. Okay. Right. Now you can have this in a PDF. You just get two pictures. But what if I want to say try different values? In this case, I would not do this. Okay, I would clear. Let's do this. Let's clear. Okay, A1, A0, A1. Now, this function clear expects any number of input. In other words, give me as many as you want. Okay, so it doesn't expect just one argument. Okay, so now it's clear. Okay. Okay, so now it doesn't know what it is. But let's just do this. Let's just allow, and this is called manipulate. Manipulate. Okay, manipulate is also a function. Again, everything is wrapped a function. You wrap function inside a function inside a function. So you wrap this plotting function inside a manipulate function. That manipulate function say, what do you want to do? That's the first thing. Comma, followed by as many things as you want to manipulate. So I want to manipulate A2. A2 from, say, -2 to 2 to 3 to 2. Okay. What else? I want to manipulate A1 the same way. Okay. And again, it's nice. It gives a little color to say, you know, are you not finished? Do you want more? Right. So now I have A0, A1, A2. Okay. And that's it. So now it's going to do this. See? Now it's going to start from the leftmost number that you gave it. So it start from -2. So this thing, let's put A2 on top. It's more interesting. Okay. So this thing goes from -2, and this just hides it, right? But you can literally do this. Okay. So now it becomes a movie, little movie of your own. Okay. And you can also play this movie. Kind of stuff. Anyway, you just so it becomes an animation. So this is right away. You can imagine that if in high school or in grade school, yeah, well, forget playing. Let's stop. So you can do this by hand. Okay, you can manipulate this by hand. Okay, and see what happened to your function. That's the essence of this manipulate thing. Okay, this is a very powerful function. Well, you know, Mathematica has thousands of functions, but this function here is especially useful for you because you want to prototype your idea. Okay, let's say your idea is to sell this equation to your client. Okay, it's like you're a grade school, you're teaching high school algebra or something. Okay, junior high. So it's like that. You're selling the concept. But if you sell it with just one picture, A1 is equal to 7, you just have that. Okay, now this tells you what this coefficient does. This is interactive visualization. Okay, so visualization, if it's not interactive, it's useful. Okay, like when I play the movie, it's not interactive because it's actually playing. You're not doing anything. But if you can do this, say, hey, I want to stop. I want to go back to say A is equal to -5. What happened? A minus 2. Say what happened? Oh, okay. A minus 2. It's like this. Okay, so you can interact with it. Okay, so this is why I want you to do. Okay, now obviously there are many things. I just told you about this built-in library, right, of machine learning. You guys know about machine learning. Say you want to classify cats and dogs or something like that, right? Well, it's the way to build it. It's very easy. It's to build a classifier. Okay, and again, go to F1. Go to F1. Okay, and tells you how to use it. Basically, it gives you an example. Okay, so this is good. So this is a training set. And let's do this. Let's do this. Let's say blue. Blue. Okay, what's blue? Blue is this, right? So let's copy that. Okay. Do you like blue? Let's say blue is pretty. Pretty. Yeah, blue is pretty. And let's find another color. This, if you double click on it, it becomes RGB paint, right? So let's say this. This is also okay. Oops. Okay. All right. All right. I have to move this sharing thing. It's getting in the way. Okay. Okay. So let's say, is this pretty? Let's say this is not pretty. Okay. So this is also pretty. Okay. And let's say let's have an ugly color. Let's have an ugly color. Okay. Somebody can show me how to get rid of this tab thing and make it vertical or something to hide away. That would be much appreciated. Okay. So let's say I have something like this. It's a little bit murky. It's black and it's ugly and gray. Okay. Let's call this ugly. Okay. Let's do that. Okay. So this is it. This is my example. I put it in the list. Okay, put in the list. That's it. That's my training list, right? I put this in the classifier. My pretty, my color chooser. Equal to classify this. Okay. That's it. Control Enter. Just doing this behind you. Okay. Now, this used to write when I was your age. Something like this would have required me thousands of lines of codes. Okay. But now it's just doing something. Okay. So now let's see what happened. Let's put in another color. Let's say this one. That's not fair because that one already knows it's pretty, right? Oops. This one, it knows it's pretty, so this one's not fair. Hold on. But let's make it a little bit not so pretty. Let's make it a little bit kind of different. Okay. So it's not the color it's seen before. It's not the color it's seen before, but okay, based on your previous preference, it says it is pretty. Okay, it says pretty. Okay, so all this algorithm, classifying cats and dogs, likes with likes, suggesting you might prefer this because you put that in your cart, and therefore you might prefer this item as well because you look at this Netflix movie, you might prefer that movie, Netflix series. Okay, it's like this. This series, fun. This series, fun. This series, not fun. Recommendation engine, how about watch this? It's similar to this, but not quite. Okay, so let's try something else. Let's try to make it ugly deliberately. I know that dark colors or greenish color tend to be ugly in this case because that's my taste. That's it. Up. Up, it's still pretty. Oh, because you know what? Anyway, it's not doing a very good job, but it's doing some job. Okay, so this is not doing a very good job. This one still look nice. Well, you get the concept. Okay, normally you have thousands of data points. You don't just have to one data point, but just 3 data points here. No, it's still pretty. Oh, I know why it's pretty because the number of ugly case is not balanced. It's 2 to 1. So let's make this. Okay, now let's rebuild it. Okay. So ugly. Yeah. So you get more example. Now watch it. This here. Every time you see a plus sign, you have the instinct to click. It knows that the input type is color. Okay, so it's RGB. You don't have to declare it again. The classes that you allow is pretty and ugly, and the method that it chose was logistic regression. Yeah, logistic regression is a very old technique. It's been around since I was born. Before I was born. Number of training examples is equal to 4. Okay, so based on this, you're already doing machine learning. Okay, you're doing a machine learning called logistic regression, but the input, it knows it's a color, so it sort of like understand what it means by color. Okay, so you don't have to put it as a number. Something like this, when I was your age, would have required maybe 50 lines of code at least. Okay, so this is very simple. That's why, if you want to learn just, basic plug and play machine learning and call yourself a data scientist, you're not. Because this is something that is, so for example, this is done. This is done. Okay, so this is the example. So the notation is, I want to build a classifier that turns blue into pretty, pink into pretty, and sort of like ugly green into ugly, and ugly green into ugly. So now I put in this. Let's say I put in red. Let's try another one. So I think a nice strong red would be pretty. That's my guess. See, that's the case. Oh, exactly. That's not very good. Okay. So let's try purple. Let's make it purple. Come on, that's pretty color. I don't know why it's taking long. Okay. Okay. So what it's doing, it's building a mathematical representation of the mapping from colors. What are colors? Color is 3 numbers: red, green, and blue. It varies from 0 to 100 or whatever scale, 0 to 1 or 0 to 100 or 60, 64, whatever. Okay. And that's it. So with this, 2 things, well, not 2 things, but you can see right away that you can get a rough first idea of very simple machine learning without knowing much about it. Okay. Now, this is something that only applies to you guys who are going to take, say, sustainability or smart cities and healthcare, where you're not going to dig very deep. Okay. But even then, and I tell you this, even then, I suggest you take a class in machine learning, because just because you can get it to work, because I just asked it to work for you, you have to know its limitation, its application. Okay? And this is important. This is important. Why? Because machine learning algorithm is a little bit like drugs. Okay? It's a little bit like drugs. Drugs are powerful. But if you don't have the pharmacist tell you the dosage, the application, it can kill you. Okay? So if you're going to just build machine learning with willy-nilly and not know what is working under the hood, it's like going to a pharmacist, going to a drugstore and just say, I want to buy this drug because it's for headache. Well, for headache, it's okay. Okay? But if your problem is a little bit more complicated, like cancer, right? Chemotherapy, you can't buy chemotherapy from a corner drugstore. Okay? So that's why you need to learn how things work under the hood. And that's why even if you're not going to apply digital intelligence track, you should take a class, in maybe not here, but somewhere with machine learning or data analytics. Okay? It's like becoming an educated consumer of drugs, as opposed to just, I have a headache, I'll take the red pill or something like that. Yeah, that could do it. Okay, so anyway, that's an example of how simple things can be, and it can do all kinds of stuff. It can measure the performance, how much accuracy and how inaccurate it is, and blah blah. Yes. It is slow because it's not a very slow machine. Yeah, that little windows that shows you the training, the progress, that's telling you that the machine is learning. Okay, but if you have a laptop that's fairly slow, then this one, by the way, in Mathematica, you can have this target device. So this option, for example, okay, so instead of, let's go back to just now. Okay, so let's say something like this. My chooser equal to classify, okay, and I have some kind of training data. Okay, I can do this, target device, okay, and go to GPU. Okay, now I happen to have GPU card in my laptop. I don't know if you do. Okay. If your machine is not configured for it, then by default, it will go to CPU, and that can take a long time. Okay. And remember that GPU is very critical. In that lecture that I talked about, emerging technology starting it. Why is machine learning, facial recognition algorithm becoming available right now? Well, it's simply because the GPU came out about 10, 15 years ago and became powerful enough. Yeah. So it came too late for my PhD, but it's here for you guys. So that's that. Okay. By the way, this is net. This is what I mean by it has a huge repertoire of machine learning model. So this is net model called the net. It's a very basic, simple thing. Okay, but it has many other things. So let's go press F1. Okay, so it has all kinds of library. Okay, so this has many built-in model. Okay, LeNet is just one. It is one of them. Okay, some of these are pre-trained. Now, what do I mean by that? And I don't want to get into this right now. Again, it's not a machine learning course. Remember that that little function here that we have, this parabolic line? Well, the behavior of the function depends not on the way you specify the function, but how you specify the value of the coefficient, right? Well, a machine learning model is like a function. That curved line that you saw, that's a function. Well, instead of taking an x, take a square plus bx plus a0 and draw a line. It takes in colors and output two values, ugly or pretty. So it is a function. Okay. Now, that function, okay, the way it works, just like you can choose the parameter a0, a1, a2, there's also a parameter to govern how you choose ugly or pretty. The training is about choosing that coefficient. Okay, the training is about choosing that coefficient. So when I say that, Mathematica has a huge library of machine learning libraries, there are two kinds of, they come in two flavors. The function that has already seen some data, optimize the parameter or the coefficient already, and then you use it. So let's say there's a built-in model here that recognize handwritten digits. There's a built-in model here that recognize cats and dogs. You can use it. So it's like equation with coefficient. Yeah. But you can also take the equation, erase all the coefficients, put in your data, and start from scratch. So if there's a function in here that classify cats and dogs, and you don't care about cats and dogs, you want to classify monkeys from chicken. Let's say it is not available. It is available. Let's say it's not available. You can take the library that classify cats from dogs, erase all the parameters, and then put in pictures of monkeys and chickens and train it. In which case, it will go through that dialogue that you saw. It would have that thing. Yeah. Now there's this thing called what's called transfer learning. I'll just give you a lot of stuff that's basically not even in this course. Transfer learning is very powerful. What it means is that trying to identify cats from dogs and trying to identify monkeys from chickens share certain basic primitives, certain components. So some of the coefficient should be erased. You don't have to start from scratch. So that equation a squared plus bx plus c has three parameters, right? That has to be tuned. Well, a cats and dogs identifier may have, let's say, 200,000. Okay. You don't want to get rid of all 200,000 to start from scratch training identifier of monkeys and chickens. You might just erase what's called the top layers. So maybe you take out 10,000. Okay. 10,000. That's 1/20th or something like that from the parameter. Retrain that, but keep the original parameter. Okay? That's what's called transfer learning. You transfer the algorithm that learn how to identify cats from dogs into another problem called identifying chicken from monkeys. Okay, you can do that. So this is very powerful. It's it's like a starter kit for your project. Yeah, but because emerging technology is not all about machine learning, okay? Although machine learning is becoming part of the regular tool, just like back then you didn't have PowerPoint and people start using PowerPoint, so everybody knows how to use PowerPoint. 50 years ago, spreadsheet wasn't a thing. Now everybody has to know machine spreadsheet. Well, now everybody has to know a little bit of machine learning. Okay, but let's get to for example a semi-realistic case. Now again, example I have here is still because I couldn't think of something more relevant now today. I just thought maybe COVID is more relevant than other things. So this is still more like a data analytics thing. And an example this, I can use this in my data analytics class or whatever. Again, it's sort of like a high school project, but you can learn from it. Okay, learn from it. That's my son who's in high school now. He's finished. I think he's finished. Okay, so I'm just going to take you through the steps. Don't have to worry about all the syntax and all the individual functions. But you can always, take this copy and just click wherever you see some question and then just go F1. For example, import F1. Okay, just simply say import. Okay, just take in the data. That's the input. Okay. Now, what I did was I import from a website. This happened to be, I think, Our World in Data website. You guys watch the daily updates on COVID, right? So this is one of the websites. Okay, and so while I import, it's gonna take a while, and I want to know also dimensions. So this is I'm doing two things. I import it, so this thing will become my data. I want to know how big it is. It's a table. It's a table. Now, why is it a table? Again, go back to here. Why is it a table? Because Poomjai has name, citizen, ID across the row. You have citizen, ID, genome, sex, nationality, religion, degree, and so forth, right? So most of the data that you will be dealing with, at least in terms of data analytics, will come in a table, meaning it's a rectangle. Okay, it's a rectangle. It has entries going down the row, and it has all the attributes going up the columns. Okay, so that's called, sometimes they call it a matrix. They shouldn't, but it's a table. It's a table. Okay, so it's two-dimensional. Can you guys give me an example of a three-dimensional data? Well, picture screen. There's an X coordinate, there's a Y coordinate, and there's a color coordinate, red, blue, and green. Okay, so we have three-dimensional. So it's not a table. It's what's called a tensor, but never mind. That's also too fancy a word. It's arrays of array. But anyway, tensor in physics has a more demanding definition than that. But anyway, okay, so it's a table. Okay, think of it as a large spreadsheet. Yeah, large spreadsheet. So how many rows and how many columns? So let me do this, and this might take a while because I think every time I do this, it takes a few minutes because it takes okay. Back then when I ran it, it has 155,000 rows and 67 columns. What it means is that it measures, it keeps a record. Okay, so it's now 160,000. Okay. 67 are the attributes of the COVID data. The reason you have 160,000 rows is because you have something like 200 countries. And each country has whatever, 2,000 days worth of data. Okay, so it's country based. Okay. Or the what? Yes, yes. The label would you so label, you shouldn't use the word label because sometimes label is like a target, like pretty and ugly. They use the word label usually to mean that, like a target, a why. Okay. In this case, it's attributes, all the attributes. I'll show you what the attributes are. Don't worry. Okay. So imagine that there's a big sheet that I just downloaded in here. It has 67 attributes, 67 measurements, 67 values each for every country every day since the COVID. Okay. So this I just say, well, it's as of today, so that's okay. The last time I ran, I think was 2nd February, so that's today. Okay. Right. So the first row, this is how you access. Okay, access. This is double. Okay. So let's say I have. Let me make another note. Let's say this is my data. My data is equal to. Okay, watch this. It's a list of numbers. Okay, the first person is 32 years old and weighs 75 kilograms, 74 kilograms. And the second person is 28 years old and weighs 50 kilograms. Okay. So in this case, let's put it in table form. So let's put name in it, ID, age, weight. Okay, I have to double quote. Okay, so that's my data. Okay, so let's put this in table form. Table form look nicer. From my data. Okay, ID, age, weight, right? So the data is going to look a little bit like this. So how do I access individual value? Okay. The row comes first and the column. So if I want number 50, okay, if I want number 50, I have to go down 1, 2, 3. Okay, double bracket. Okay, 1, 2, 3, comma 1, 2, 3. 50. If I want 74, I go down 2. Okay. Now, if I want ID or age, if I want the word age, I go to the first row and second column. Right? Now, if I want to know all the information I have in this data, I just want to say, what does this data contain? I just want one and all. Okay. Okay. Now, you can omit all. Okay. But if you want the second one, if you want age, you have to go all and 2. That will give you age. Oops. Okay. So this is how you access this double bracket. This double bracket. Okay. So in other words, this is an argument, and this one is to say it's to take that part, know how to go down and go to the right. Okay. So this represents something like go down I, go across J. So that's how you access. So if I knew this, this is how the data looks like. Okay. Now, sometimes you would get what's called metadata. That's a description of what the data said. So in the website, it would tell you this. But I already know this, so that's why I don't have to. Okay. So I say orbit hour in data, COVID. Okay. The first row, that's 67 of them. ISO code, that's for country, continent, location, date. So basically, these two are the ones that I was talking about. There are 200 locations. The reason they don't say country is because sometimes you remember the beginning of the pandemic, there were cases in a boat, not a boat, cruise ship, right? So that's not a country, okay, but it's a location. Okay, so they use the word location. And if it's Thailand, continent is Asia. If it's something like a cruise ship, they say something like global because it doesn't belong anywhere. And then the date. So these are actually identifier. ISO code, I think that's a country code. Continent is where the country is. Location, again, the country, mostly the country. Get 200 country and date. So it's going to have anything from Antigua to Zimbabwe. Okay, but Antigua from maybe the first day it has a pandemic. Yeah, in the first day, I don't know if it's the first day of the global pandemic or the first day for Antigua. I don't know. Okay, I think it's first day from Antigua until present day. And then these are all the numbers. Okay, total case. This is a little bit like when you go to it's hour in data. It's the same thing, similar to world. I think you see that a lot more. You use that, right? Except it's more detailed. Okay, so I think this one has what has cases, death, right? Oops. Has add, obviously. Our world in data, where is it? Oops. Never mind. Okay, but anyway, this is a lot more detailed because it has 67. So it has all this. Total vaccination, people vaccinated, booster, age 70 or older. Okay, so this is going 67 items. The first 4 are sort of like identifier, and the other 63 are information. Okay, so 4 reference field and so forth. Okay, so these are the reference field. Now, what I do is for and this is to make life easier. This to make life easier. I say, okay, this is my reference field. That way, I can say, I'm just looking at Thailand because I know that eventually I want to look at information on the right-hand side, you know, from column, the 5th column onward. But I don't want to look at every country. So I'm going to say these are the reference fields so I can pick and choose what data I'm looking at. Okay. Now, don't worry. This is creating what's called a data set. A data set is basically an association. Association is like a list. But instead of listing ABC, I list key and value. So for example, instead of having a list of your ID and your name and blah, 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 I can say, well, the ID is the key, right? Because you can have the same name. So I'm going to say a list of ID with an arrow pointing to the other value. Yeah. So even though you have 5 attributes, the first attribute is ID is a key. The other 4 attributes are called values. So I make this thing called association. Yeah, association. I associate ID with your number, with your attribute. In Python, it's called dictionary. Same thing. Okay. So I create this COVID data set. So now I can play with it, right? I can say, what does this do? Okay, well, this is actually just, there are 60 characteristics. I happen to be noticed to be interested in just 14, let's say. Okay, this is to make an exercise manageable. So I handpick this from this. So basically, I just copy this and put it down here and erase the one that I don't like. Okay, so I care about this. So I make header of COVID time series and I put length around it just to make sure I can count. I don't like to do manual. Again, and now there are two kinds of statistics that I want to talk about. One is the statistic on the, which is like a time series. Okay, so this will be something like daily for every day. But I also want something like the latest. So for example, things like population. I don't need to know the time series, for example. Okay, so this is the latest stat. So I just happen to have two categories. Okay, now this is called, this is just one liner, but in real life, I tell you, this takes you weeks because most of the data that comes to you is dirty, it's messy. Mr. and MR is the same thing, so you have to, turn that name that has too many space. So this is sort of like a cleaning. So this, I replace the word, continent with planet if there's nothing. So for example, that ship, the cruise ship, the continent is blank. I don't want to deal with blank, so I just say, well, it belongs to this planet, so I just stick the word planets in there or something. Okay. So anyway, and if it's blank, I just put in 0. So replace all blank with 0. Okay. Some analysis takes blank as missing data. I just want, for simplicity, just take it as 0. Okay. So I did that, and it's running right now. Hopefully, it doesn't hang. Now this is where the reference comes in, right? Reference comes in. It's the word. It's the function group by. So I have the reference tools, reference field, right? Group by is to say, let's group by country and do something. So if I say group by country and I say maximum daily cases. So what it's going to do is group all the dates, right? Because every country, Antigua has maybe been infected for 2 years. So that's 730 data. So group them all together under Antigua, take the maximum and keep it. Go to the next country, Bahamas, takes also 700, take the maximum. So that's kind of group by kind of thing. Okay. And this is the group by is a way of defining. So I create another. Oops, sorry. I should have run this before come to class because it's a huge database and this is only a. Did I restart this? I think I must have something. Oh, sorry, sir. For some reason, I think I restarted it. Okay, so anyway, I'm just gonna run through. So what it's doing, it's creating a database. Looks like a bit like this. Okay, it's like a spreadsheet, but now I can reference. I can say, go to continent, pick up just the group by Asia, and do something. So something could be the average, take the maximum, plot. I can do whatever I like. Okay, and that's what I mean by this being a reference field, and again, location. So this Afghanistan has, oh, this is already grouped. Oh, this is the latest, right? Okay, yeah, this is the latest. So this one takes the latest. Afghanistan, the latest is 18th of January. Why 18th of January? Oh, this was from the previous one. Okay, so I did this. So anytime I see the blue, I have to. It hasn't been run. It doesn't know. Okay. Hit enter. It becomes black. Okay. So if I close this program, like apparently I just did and turn it on again, the variable would be blue again. Okay. So now this is a data set. This is the arrow. Okay. Table, the list, but enumerated. Don't worry, it's useful, but it's one of the most useful constructs. It's a way of writing the list. Okay. So it's a table, okay, that points, okay, from this to that, going from I to number of columns, going from J to number of rows. Okay. So this is using this thing as an indexing. So I'm taking a flat data sheet and making a reference system in it. That's it. That's all it is. Okay. And okay, let me enter that again one more time. I think I understand again. By the way, I never do anything professional on a laptop. Okay, so this is the input. If it's not done, it's a running. If it's done, this one is going to have an output. Right, I'll finish. Yeah, so this is taking a while. It's going through all the thousands of lines and replacing. Okay. Okay, when that's done, this is going to give you an output because I asked for the dimension of the data set. It's running in a minute. Okay, and this is okay, now it's out. Okay, fine. Go to the next line. Set. Local stats. Anyway. Okay. So that's the sort of thing. So see, it's kind of doing all the group by and all kind of stuff. So that's not the important thing. That's all tedious. So in Mathematica is a high level language. You still have to say something. And this is my, I'm just making a few things. Don't have to worry about oops, latest stat. Anytime something is blue, I have to go back and say, okay. Okay, this one. So the reason this is taking a long time is because I'm actually taking the whole data and I'm making what's called a data set. By the way, for those of you who are going to learn Python, the most important tool in Python besides the basic is pandas. Pandas is like a data frame. Data frame is the same as data set here. Okay, so you can't really do much with tabular data without pandas. Same here. Okay, so I'm going to make a list of location, make a list of countries, and so these are housekeeping. So I know that I'm referring to country, I'm referring to people, I'm referring blah blah blah. And now the first thing I want to do is I want to list a data set time series. Data set time series to blue. Blue. Okay, every time something is blue, data set time series. Oh, it's not blue. Weird. Okay. Shouldn't be blue. Why is that a set time series? That is the time series. Okay, that's it. There's something undefined here. It's not pretty. That's my data set time series. Horticulture time series. Let me try that. Okay. Here we go. Oh, okay. Apparently, I changed the name for some reason. Oh, that's not good. Well, anyway, that one didn't work, but this one works. Okay, so this is the manipulate. Now, obviously, I'm manipulating something. Okay, so this is the action. All the action has this parameter: location, date, series, and so forth, right? So the location is from the list of locations. Okay, series is from the list of series. So there, it display. Now the location, the default is world. I make a default world, and I say series is new case. So now instead of having just a graph like you have in a report, you have interactive report. So instead of having a plain text in a PDF, this is a computable text. Instead of having a presentation like PowerPoint, this can be turned into a PowerPoint, but with interactive. So in fact, professionally, sometimes I use PowerPoint because they ask for PowerPoint. It's easy for them to turn on and stuff. But if I'm presenting on my machine, I'm actually presenting PowerPoint kind of slides, but instead of having something that's just flat, I literally have something that I can manipulate. So imagine that this is a PowerPoint. I would say, okay, well, you can see this is the world, and let's go to, I don't know, let's say Thailand. Thailand. Okay, Thailand. Okay, and I can look at new case. I can look at new death. Okay, now you can see that new death and new cases look similar, except when we have this Omicron, we have new cases but no more death. In other words, it's not as much death. So this is where we have this Delta wave thing, and this is where you have the Omicron wave. So it's more contagious, but not so deadly. Okay, so you can do that, and you can I can view it as time series. So this is data point. Time series means this, So this is how I would imagine, or I would want you to pitch your project idea. So in this case, it's about data, right? So you can imagine that your project seed class, you want to do something, sell these bottles, and you say, well, the demand for bottle has been growing exponentially, and then you show the graph of bottles, okay, or something, okay? And this is going to be very powerful, especially when it comes to sustainability statistics. Like this carbon, there's a very nice graph that say, before we walked upright, the global temperature varied a lot, but at a very low level. And then it gets a bit higher and more stable. And then we came along. And then it came a bit higher when we industrialized. Now the risk is not just it's going to be higher. The risk is that we're going to throw things off balance. It becomes volatile again. So all this graph, this time series is very powerful. Okay, so tell a strong story with numbers and figures. Okay, so this is not even your product yet, right? This is sort of like a preamble. Why do I need to make this widget that makes better bottles? Because people have been using bottles. I don't know. I don't care. My example tends to be fairly irrelevant, but you can imagine that. Okay, so how about this is one way of visualizing. This is saying, oh, different countries, right? Different country. This is country, time versus statistics. That's it. Okay. Whatever you want to look at. Hey, let's look at vaccine. By the way, I want to see. Okay, we got pretty good vaccine. Okay, good. Okay. Okay, so we got pretty decent vaccine and so forth. So that I'm happy with that. Okay. Now, this is let's view latest stats, but instead of looking at every country, each country as a time series, say, let's look at how they stack up. So this would be something like looking at the latest date, okay, the latest date of data, and look at in this case total cases versus total death. So Thailand is somewhere in here, somewhere. Thailand, there's Thailand. Okay, yeah, total case, total death. So you don't want to be Romania, where it has the same kind of case but a lot of death, right? Oh, well, you don't want to be anywhere up here. You want to be down here. Let's look at total death per million. Okay, that's okay. Now Thailand, if you look at death per million, Thailand is going to come down here way back. Okay, because we have a lot of cases and we have decent amount of death because we are, I think, number 20 in the world population. We are a big country. You don't realize that. So in terms of population, we are pretty huge. So, but per million is quite small. So if we go to total case also per million, let's say total case per million. So total death per million is quite small. Total case per million is going to be in here somewhere. It's quite small. Okay. Right. Population density and all that, all kind of stuff. So this is what? This is representing 2. Okay. So we have again, how many attributes we have? We have like 67 column, right? 4 of them are identifiers, so we have like 63 of them. I decided not to look at all of them. I'm just looking at 14. Okay, and out of the 14, I can only look at 2 at a time. Okay, if I'm looking at the same total death, and then it's going to become a straight line. That's not interesting. If you know, total death, it's going to be a diagonal, right? This is much, even with the GPU or whatever, and this is fairly high spec laptop, it's much slower than a laptop. Okay, so for my money's worth, I never do anything with a laptop, but I have it carried around. Okay, anyway, so some reason I reduced another set. Okay, so now I'm comparing continent, but I'm reducing further because I want to look at a few, even less. Now, over here, the function I use. Okay, first of all, the first function here is list plot. Okay, list plot. So list data and plot them, obviously. This function here is also list plot, but different data set. So instead of time versus death, it's death versus new case or population, so forth. Now, I'm going to look at something else. I look at the latest date, but I want to compare. I can't compare 200 countries at once, but it's too much. So I'm just going to compare continents. Okay, I'm going to compare continents. I'm going to use what's called radial axis plot because for the dimension that I'm interested in this case, total case, total death. Okay. Again, this is 14, right? And then 1, 2, 3, 14. Okay. If I have 67, it would make sense. Now, what's nice about this is that it puts Asia versus Europe versus Africa versus North America versus Oceania. And this is giving you a sometimes called radar plot, sometimes called cobweb plot, depends on what your name is. And another thing is I can overlay population size. For example, Asia, you know, the thickness is proportional to population. Okay, and now, so let's look at what stands out about Asia. Well, Asia has high population density. Okay, relatively young, age 70 years older, much less compared to, let's say, this one, Europe. Okay, And let's look at what's pink, South American. So for some reason, total death, South American is very high. Okay, so total case is high, total death is also high. So this is sort of like some kind of like a continent average, I think. I'm not quite sure, average or total average, I think. Death rate, okay. Death rate is, what do we call? What's the word? Cardio, oh, this is not COVID, this is cardiovascular death rate. This is a heart disease. So this is looking at other disease, this prevalence. Let me move. Okay. So diabetes, right? So apparently Oceania have a lot of diabetes. You know Oceania, right? They're the country's island country, and they prefer to be fat because in the old days, when they go from one island to the other, they may not survive. So they prefer a fat diet. But once, in agricultural comes along and we get easy food, they just eat much. Hospital death. So this is kind of like a visualization. Again, these are our visualization tools. I'm not using any advanced machine learning here. This is all plotting. Yeah, this is all plotting. And I can view, oh, this is continent average, and this is another one, I think. Okay, so that's just plotting. Then let's look at some analysis. Well, then you can start looking at things like, okay, what am I doing here? This is clustering analysis. Remember when we have these country plots, right? Imagine that. Let's go back to this. Now, let's say that you can separate people, countries into groups. You can say maybe there's one group here and there's one group here. Okay, that's grouping based on how many dimensions? 2. Okay, so you can eyeball it. I can eyeball it. I can say, well, it looks like we got the one group here and everybody else. Or let's look at something more interesting. I don't know. Okay. Well, maybe here there's only 2 groups. There's here and there's everybody else. So that's like whole economy. Okay, you can eyeball it. That's the whole point. Clustering, you can eyeball it. What you cannot do is eyeball in 10 dimensions. You cannot eyeball in 10 dimensions. You can eyeball in 2 dimensions. It's a little bit like when you look at the stars at night, you see constellation, right? The stars are together. Actually, they're not, because the distance, this one could be like a million light years. This one could be a billion light years away, but it happens to be in that location. Okay, so you can cluster the star in 2 dimensions, but in 3 dimensions, you actually way off, way off, way off. Okay, so this star here and that star here may be very close together because they're both, 100,000 light years away. But this one and this one is a million light years away. Okay, you can't see that in 3 dimensions. Well, that's where algorithm like cluster analysis comes in. So it does the clustering for you, and this would be something like clustering. And Thailand used to belong to a very prestigious cluster of very low incident, but now I think we moved up. So I think we got mixed in with everybody now. I think we are in here. I think Thailand. There it is. Okay, because of the incident. And then we have different. Now, here's the number of counts. 20 locations clustered together in 14 dimensions. 180 countries clustered together, right? But then, well, you don't know anything about the cluster, right? Are they here because they are low case or high vaccination or diabetic or whatever? Then you want to visualize. So again, you can only visualize in 2 dimensions at a time. So let's do that. But at least we do it by cluster. Okay. So we go back to the same thing as before. So cluster, and then you choose, these are all the free parameter, right? Choose what do you want to cluster by, blah, blah, blah. Enter. Okay, it's start right now, so it's running. Give it a minute. Enter. Okay, why it's taking so long? Usually this doesn't take all that long. Okay. Anyway, I'll just tell the story. So instead of viewing two, you want to do the radar part again. Except now it's more clever. Instead of grouping countries by Asia versus America versus Oceania, which is by geographic definition, you group them by natural clustering. So the shape will be a lot more diverse. One group would sort of like maybe high in death rate, but low in vaccination. One group may be high in whatever. Okay, so those are the analysis. Okay, now this requires a little, yeah. In this case, once it's done, because we have 4 clusters. Okay, you can specify number of clusters you like, but if you don't, the machine will automatically pick for you. So this is what I mean by a lot of under the hood calculation is done for you. I don't know why this is taking weirdly long time, but anyway, it's never. So what I did, ended up looking something like this. This is from the previous run. So okay, so this cluster 1, cluster 2. So you can see that the shape is a little bit more diverse, right? Because you use it, because we actually use these 14 dimensions to cluster them. That's why each line are very different. Okay, so this yellow is very different from this blue, from here, and there, 4 lines. Okay, now this is something else, a little bit more interesting. It's called dimensionality reduction. Because my thing hangs, so I'm just gonna not spend too much time on it. We used to be able to watch 2 dimensions at a time, right? Yeah. So we can see the countries that are close together in those 2 dimensions. What dimensionality reduction is? Again, computer algorithm. Yeah, it's already built in because there's a big library here. What it does, it says, what if I compress 14 dimensions into 2? And those 2 dimensions has no meaning in real life, but it's a summary of 14 dimensions that has. If you compress the 14 dimensions into 2 dimensions, you can plot them. The only nice thing, or the only thing that you would require one of this is that you don't know what those dimensions mean. It means nothing. Okay, it's horizontal, vertical. But the requirement is that countries that are close together in 11 dimensions or in 14 dimensions are closer in 2 other people. So if you think about it, if you did this dimensionality reduction first, you can also do clustering with your eyeball, right? And in fact, the result will be similar. Okay, you would see that when you reduce the dimension from 14 to 2, the countries that the machine thinks belongs in the same cluster will look to be close together in the 2 dimensions. Okay, I'm just using my hand waving because for some reason this thing hangs. Okay, and this thing went on. There's some the whole paper is shared, I think, in paper with code. Okay, so if you go to paper with code, again, paper with code is a very good paper with code. You search for, what's the search? Search button. What's the search button? Okay. Analysis of global COVID-19 data. Oops, not COVID-10, COVID-19 data. Okay. It's a few papers. There's even newer one. Okay. Now it's a little bit older. Okay. So let's put my son's name. So there's a lot more papers since then about COVID data. Obviously. Okay, so the paper is here. Okay, the paper is here and the data, the algorithm is there. But oh yeah, there it is. Now, what this paper did, well, the data is probably before Omicron, so it's not that relevant now. It also did what's called baseline analysis. Okay, you can't really predict cases from all the attributes like diabetes or population. You can't predict. But what you do is, if you make the prediction, you try to make the prediction, okay, with linear regression, you can consider that a baseline fit. So based on Thailand's data, number of people over 70 years old, prevalence of diabetes, cardiovascular disease, vaccination rate, this. So in other words, out of the 14, you take 13 as input and take the case date, the case count or number of cases as the label or the Y, and make the prediction for all the countries. Okay? The prediction is going to be very inaccurate, but what you can do is to serve as a baseline. Say, given the 13 characteristics, you would expect Thailand to have this many cases, and then you compare actual versus baseline. Okay, so we are doing pretty well. I think if the table hasn't been erased, yeah, there it is. Okay, so something like case per million. Okay, for Thailand, baseline would be 66,000 case per million. Okay, but we actually have 33,000. So we actually have the baseline. Now, some other country, obviously, you go to United States, it's a different story, right? They're outperforming. Okay, they're outperforming South America as a whole. So this is done by country as well as by so case per million, death per million estimate. Thailand should be about, yeah, we should have about 1,800 deaths per million, but we have about 1/6 of that. So we're doing even better in terms of death. I think South America is doing terrible in terms of death, if I remember correctly. Yeah, Brazil, for example, is terrible. Okay, Africa is very good as a whole. Okay, as a whole. Okay, Oceania, blah blah blah. So that's the world. Okay, so this is where you have this kind of baseline average cases. So actual versus fitted. So Thailand, I think what was this one? Case per million, right? So we should look for 66,000. Actual 66,000 to be around here, and we are about 33,000. So Thailand is somewhere in here, I think. There it is, Thailand. Okay. So baseline is basically the 45-degree line. Okay. So if the fitted is less, that's good. So you want to be above 45-degree line. Okay. Actual here. So this is not good. Gibraltar is not good. Okay. Right. Actual fitted. Okay, so all this is very, it looks a little, by the way, I promise you, the reason this code looks 50 lines long is because of formatting. It takes, I have to say that Mathematica is elegant when it comes to mathematics, but when it comes to formatting, it takes quite a few lines to say, I want to make this boldface, I want to make this yellow and green and arrow to the left, arrow to the, so formatting can be a bit of a pain. But I don't know any other language. I mean, even Python is even worse with GT+. Okay, so formatting is something that certainly is a painful thing. But if you want this basic plot, basic analysis, it's only 2-3 lines. Okay, I'm not going to save this, by the way. Good. So that gives you a rough idea, right? So we talk about this thing, and again, I put this URL in here. So URL is I think I put that in here somewhere. Class 3, class 4. Okay, so today is class 4, class 5. That's analysis of COVID data. Okay, so go look at that. Now, that one certainly has so many little interactive pockets, right? So each one of those could be like a demo program. Okay, I think Mathematica has a on that demo website has a policy where the demo has to be self-contained. In other words, can't access live data. Okay? So this one would not, I would not post this on the demo. The demo would be something that's self-contained. The data is in there. Whereas this one is loading data live. Okay? So demo is not, again, demo is a demo, right? It's not meant to be. But this is something that I can literally use. I want to see if Thailand is now edging closer to its baseline or not. Okay. And so far we're still doing pretty good. So from the baseline fit, right? We are half as infected as the baseline. We are 1/6 as deadly as baseline. Per million, everything is per population. So that's pretty good. So I'm okay with Thailand's COVID response so far. Okay. In fact, if you, I don't know if you know this, but long time ago, when when COVID just came out, like 3-4 months, right? I did a COVID prediction model. Okay. Now, unfortunately, that COVID prediction model only takes one wave. In other words, it has the initial starting point and works out how long you will have. And that model was extremely accurate, to 180 days or something before Delta. So basically, once Delta comes to the second wave, the model has to be rerun or whatever. That doesn't make sense. But if I think if you go to YouTube, it's still up. Up. If the what, sorry? Text. Okay, that's very good. Okay, let me just find you. Okay, that's the COVID analytics. I built a little model, so you can watch that. Okay, that's explanation in Thai and in English. Anyway, okay, let's go back to what you were talking about. Well, this thing is called. Okay, that's the app. That's they measure the. I'm quite proud of it because it was very accurate up to the first wave. Okay, let's go back to here. Okay, let's go to. Let's search. Let's zoom. what you are looking after, what you're looking for is what's called natural language program processing. Okay, so let's go to Google. NLP. Okay, this is called, well, no. Okay, if you see the word neuro-linguistic programming, forget it. Okay, that's about sort of psychology thing. Okay, that's not what I'm talking about. It's a natural language processing. Okay, not neuro-linguistic, but that's sort of like psychology thing, like programming your mind to be happy and something. Okay, natural language processing. Okay, huge in Thai even. Okay, but let's say in Mathematica, so I can show you the example. Okay. So here, what it does is this. And by the way, this is a demonstrator. Well, let me just give you a note. You are asking about natural language processing. Okay. You guys remember what I just said about compressing 14 dimensions to 2? Yeah. Yeah. What's important is that those 14 dimensions, in this case, they're all numerical. They're numerical. I compressed them to 2 dimensions. So it's 2 numerical to numerical. But the 2 numerical dimensions I ended up with is nonsense. It's nonsense. You can't say that, you know, to the right is good or bad or whatever. All you can say is that it preserves the quality or preserves the closeness. Okay? So 2 data points that are close in 14 dimensions are close in 2 dimensions. Okay? So you don't have any more representation. It means nothing. But how about this? How about I have words? I don't know what dimension words exist in. I don't know what dimension words exist in. But I'm going to make an algorithm that turns words into 2 numbers. Just like what we did with dimensional reduction in 2 numbers. Such that if I have the word cat and the word dog, they are closer together than the word cat is to the word refrigerator. Exactly. Except in natural language processing, you're not trying to visualize the word. So there's no reason to stay in the 2 dimensions. What ended up happening is something like every word in the English dictionary gets mapped into 300 dimensional numbers. Now, ask me why it's 300. It's a practical number. You need enough dimension, because if you have 2 dimensions, you can't put all the English language and preserve that closeness, because you have cats and dogs here, but then cats is also close to mammal. So mammal is also close to whale. Whale is also close to fish. All kind of stuff. Okay. So 2 dimensions won't cut it. 5,000 dimensions too much. So the engineering decision, let's call it engineering decision, was for English language, I can represent every single word in English by 300 numbers. And I have a mapping such that cats and dogs are closer together than cats and refrigerators. Why are they close together? They are not close together because in your mind they're close together because you make this map, right? Cat's a mammal, dog's a mammal, blah, blah, blah. But computer has to learn from, in this case, not from logic, but learn from example. Well, it turns out that when you talk about cat, okay, I love my cat, I love my dog. Words like I love my cat, I love my dog appear together. You never see words like I love my refrigerator, right? So the similarity is not conceptual, but contextual. Dogs and cats tend to appear together in similar context. Okay? So you have this gigantic machine run by Google, much bigger than this, much bigger than this huge machine. Looks at all the language text in the internet, not just wiki page, everywhere, all the pages that Google can get their hands on, and Google can get their hands on everything. Okay? Make an algorithm with one requirement, that the mapping from words to 300 numbers is such that words that appear in similar contexts have similar 300 numbers. So they're clustered. Okay? Now, there's a magic of how that happens, and I can tell you how that happens with the algorithm. And I can teach you it, but certainly you're not going to be doing it yourself because you don't have the capacity to get, first of all, the language is called corpus. It's the body of language. It's not just syntax and vocabulary like in a dictionary. A corpus is how it's actually used in the world. So even though the dictionary in English language has, self-contained, has so many words, how do they appear in language? You see cats and dogs here. How many times do you see it in the internet? How many times do you see a refrigerator in the internet? All of this is considered a corpus, English corpus. This English corpus has been digested by Google. Google creates this natural language mapping. So once you have this, you can do something amazing. Okay? One of the things is this. One of the amazing things is called word algebra. Okay? A plus B is equal to C, right? Therefore, C minus B is equal to A. Right? Okay. Well, they take the word king, turn it into 300 numbers. Take the word queen into 300 numbers. Okay? All kind of stuff. You can do all kind of stuff. Okay? They take the word king, 300 numbers. They take the word male, 300 numbers. They take the first 300 numbers, subtract the second 300 numbers. Then they add another 300 numbers corresponding to female. King minus male plus female. The result is the word, and you look up what is the nearest word to that. Nearest word to that. So even though you can't say king minus male plus female equal to queen directly, you can say the vector, the 300 numbers called vector. Okay? I'm going to use the word vector. It's a vector. Vector is a list of numbers of that dimension, 300 dimensions. Represent word. The word vector of king minus word vector of male plus word vector of female equal to the word vector that crosses in the English language, queen. Right? So you can imagine that now the relationship that is applicable in, after all, you're doing all kind of machine learning is based on mathematics, right? Now you can do things like sentiment mining, not mining, but literally modeling. Okay, modeling. You can say, why the word is, say something like, oh, this is so nice. That's a good compliment. This is not very nice, or this is terrible, or this is disgusting. I mean, all this stuff has quantitative assignment. Okay, and you can imagine that things like like you know, extend. You can say something like ugly is a word in that direction. Hideous is like that direction, but really far out. Unpleasant is that direction, but not so far out. You know, this kind of thing of direction, multiplication, addition, become, yeah. Yes, yes, yes. So I don't know if you can literally do this, but let's guess. I have never done this, but let's go to internet and word vector embedding English online. Maybe there's a word vector for okay, so this becomes like a library. You can't, you know, what would be nice, although it's not useful, is to say, I put in the word dog and give me what the 300 numbers are, okay? But certainly, now, this is where Mathematica can't fight Python, because Mathematica only does natural language processing in English. Whereas you guys are Thai, I am Thai. The Thai corpus has also been absorbed by the two people at Vistec. And the Thai embedding, because they use a Python as a platform. Okay, Thai word one done embedding. Actually, I think it's in paper with code. What's the line of search? Yeah. Again, that's visualization in 2 dimensions. Normally, the real thing is in 300 dimensions. Thai language verb. Why isn't it there? Anyway, it's there. Let me just show you the pic. I have to go to my own library. I have a huge library of machine learning, obviously. Natural language processing, and I think go to Thai. Thai. Yeah, it's this one. It's this paper there. Okay. Wangjan Berta. Okay, that's the name. Let me try again. Why is it not there? Wangjan Berta. There it is. Okay. So yeah. But I downloaded it obviously. Okay. So this one here is built on. It uses what I was talking about transfer learning earlier. What it does is, this is something that you cannot do on your own. No individual person can do. This tech has, in connection with data consortium, people who provide them with data. So I think they even got data from Pankit. They got data from Twitter or something, all kinds of stuff. So huge data, and they run the supercomputer, meaning you know, the CPU card, the GPU card, it costs what, for me, I'm about to buy one that's what 70,000 baht, right? Well, they got one that's like 200,000 and four of them, or something like that. But anyway, they got millions baht worth of hardware and they run it for 8 months. So this is not something simple. Okay. So I can teach you how word embedding works, unless you have a million baht worth of machine, access to huge Thai database, and 8 months of air conditioning running straight. Okay. I suggest you don't. But anyway, they have done it. They have, I think, compacted to something manageable, like an encoding. So it becomes a dictionary, right? You look up the word sunak, and it has 300 numbers. Male, 300 words, 300 numbers. And then you can do all kinds of machine learning from it. Okay. So this is just to your answer, exactly your answer. You can do all kinds of machine learning with numbers. What can you do with text? This is what you do with text. Then this is a concept called embedding. Embed things that are not numerical into a vector representation. So once you got this thing called text embedding, you can start thinking of something else. People have gone on to start embedding all kinds of crazy stuff. So you can say, how about instead of embedding words, how about embed sound? How about embedding relationship? Your relationship on a social network. Yeah, your is a graph. Looks like what you saw just now. Okay, but that, by the way, that's a terrible number to put because you can't put in a single number. Okay, I can't put in your information like just now we have different countries, right? So that's one country, do regression, data. Well, with social network, I can't put you as a single data point because you have friends. So now I have to embed information about your friends. Okay, so think about it. Graph learning, graph, by the way, doesn't mean what is graph, it means this network that we saw a picture. Okay, so I have to put in your attributes. Your attributes give me an idea of why you might or might not like this product. But would it be better if I use who your friends on the Facebook is? So because chances are your friends you are influenced by your friends. So instead of looking at your attributes, I look at the attributes of your friends plus the quantity that signifies how much that friend needs you. So it could be the opposite, right? It could be, you know, you follow somebody on Facebook and you really hate this guy. So if he buys he likes Coca-Cola, you drink Pepsi, whatever. Okay. So there's information about you. There's information about those you're connected to, and there's information about your connection. Okay? Do you like to follow this guy? Do you like to do the opposite? Do you ignore him? Whatever. Okay. All of this is no longer simple numbers, but it follows the same kind of idea that if you think about it, this is makes the dimension big. And you reduce that again to 300 something. Okay, that's called graph embedding. And that area has exploded since 2018. Okay. I'm doing a project on it. Okay. So text embedding was the sort of like inspiration. Because you really can't stick words into a computer, into a machine learning. Okay. And now, so Mathematica will wrap all this under what's called net encoder. Net is the neural network. So you encode things to feed to the net. And that works with a large class of data. And that's what if you take my big data class, that's the variety part of data. In other words, data is not numerical. But you can't do anything without making it numerical in a way that makes sense. And the way that makes sense is things that are similar and numerically similar. After all, that's how everything works, right? I'm going to make a cancer prediction. Well, somebody's going to be diagnosed with cancer because the numbers are similar to those who got cancer, right? So there's always, at the end of the day, it's always about closeness. Okay? Because there's no other logic you can learn from data. It's also association. And in fact, this is from day one when you were born. Why do you love your mom? Because you associate the process of the smell of your mom with being fed. Okay? So it's always closeness that underlines all the functions. Okay? So that's it just it's the fundamental. Anyway, so this is it's called pre-trained. See, so this one they already did it for you, so you can just use it. Okay. BizTech is a university, so most researchers when they do this, they make it available online anyway, share. So there's no reason for them not to share. So they share this PDF, abstract, get data. So this is when you go to here, that's when you can download all the libraries. It's this kind of library. It's this kind of it's this kind of generic library. Okay. Now you can then use the BizTech library to build a model for chatbot, let's say, for talking and then suggesting a good product, or not, and then you can share that. That becomes a task specific. Yeah. So, oh, it looks like we're kind of running out of time. I was kind of hoping that we would get to but anyway, so that's okay. Let's make it next time. I think I have scheduled for next time to be Professor Luis Pontiac who will teach you about nanotechnology. Okay, but again, think of this computational visualization, prototyping as a tool. So it would be really wrong if you think that, oh, I don't have to learn this because I'm not going to apply digital intelligence. No. Okay, it's going to be everywhere. Okay, so that's why the way I design, the way I think of this Barsai curriculum is everybody has fundamental programming skills. Everybody has basic visualization and prototyping. Now, unfortunately, visualization and prototyping in Python is not it's clumsy. It takes you a lot of what's called boilerplate code. Okay, but it has large community, so if you have time, you can always find your way. You can go to the internet and ask your friends how it's done, blah, blah, blah. But it takes a long time. It's also mathematical community which I use. But anyway, it's a lot more higher level language. So everybody in that side should do that, whether or not you in sustainability, smart cities or whatnot. You prototype, you visualize, get your idea across in a better than slide. Okay? If you go through 4 years of Basai and you can make a very good pitching session with PowerPoint, then we fail you. Okay, you could have done that elsewhere. You don't need to come to Basai. Okay, but if you actually have an interactive display of your concept, with 3D visualization, with interactive mode, whatever, okay, then we've done a good job. But if you just know how to make a pitch, a sales pitch with a slide deck, so you didn't get your money. Okay, but then if you go to apply digital intelligence, you have to go deep. For example, if you work in high natural language processing, mathematics is not an option for you anymore because they haven't embedded that language. There's Japanese, Chinese, but not Thai. Okay? So a lot of it, the tool, you go where it's popular. This is where popularity counts because it's the popularity of developers. Okay? Why is Python better than R? R used to be better than Python for statistics. Okay, but for a lot of things, you go to Python. But if you're working in, let's say, genomic research, that's a huge community of genomic or genetic engineers who program everything in R. So if you go in that space, you better speak R, right? Because they speak R. It's a bit like that. It's a bit like that. Okay? So don't have any prejudice about this or that. It's always about where you can get the most bang for your effort. So anyway, we kind of out of time, unfortunately. So you know, not much new here. Go to your homework. Your homework here is, well, since we couldn't do it in class, how about you do some kind of can you guys do video presentation, 5 minutes, each of you? Yeah, you can do this. You can go to Loom. You know what Loom is? It sort of records video screen. I use it to do this in my video here. Here, yeah. This was recorded on Loom because basically I wanted to show the apps I developed as an app. So I play with this and I narrate. So you can do that with Loom. I think it's called Loom, if I'm not mistaken. Yeah, video thing. Get plenty of things. But I think that's the one I use, if I'm not mistaken. And I did it from home because we were under lockdown, so I think it's even on this machine. Loom. Yeah, Loom. It's Loom. Okay. And your PC. Yeah. Okay. So that's Snack Cup. I think we are pretty good. We can stop the recording and
Okay.
Peanut's not here because not under quarantine. Okay. See blue and brown. See good stuff.
Okay, then I will
Okay, Cup.
stop the recording.
Okay, so